everyone, and welcome back to Dev Show. My name is Sherry List, and I'm your host today for this 15th episode of Dev Show, together with my good colleague Rasmus Jack. So we are here today with a really interesting topic, which Rasmus is going to talk about it a little bit in a bit. And also is going to introduce our speaker. But before that, as usual, I want to encourage you all to use our chat functionality to ask your questions during the session from the speaker, because we have a dedicated part of our show, which is our Q&A, and our speaker is going to answer to all of your questions. Also, let us know that where you're watching us from, and but please familiarize yourself with our code of conduct, which is listed on our main meetup page. We really want to have a kind of an inclusive environment for everybody, and we also have some present for all of you. Which is our Azure Heroes Learner Badge. I'm going to talk about it in a bit, actually not after the show, but I'm going to highlight the kind of the link to get it as well. And if you are filling up our feedback form, which we are going to also highlight the link as well later on, one of you will also get a care package from DevShow. Okay, Rasmus, I'm handing it over to you.
Yeah, thanks, Sherry, and welcome everybody. And 15th episode. Time flies, huh? It's amazing. So I hope everybody has followed us through with all the interesting topics we have had along the way. And no less interesting topic we have today. It's actually amazing, as Sherry said. So the topic of today is how to deal with the persistence in serverless applications. So that's something that is really relevant for any developer here. So what's gonna be in this topic today is, of course, you're gonna learn, as the headline says, how you will deal with the persistent data in the serverless application, but also high-level overview of blob storage, table storage, CosmosDB, and durable entities, and how they can work together in a combination with Azure functions. So kind of moving up the stack here when you're developing. So to get us the insight and present the topic today, we are so glad to have Mark and Mark, I'm just going to do the intro of you. Welcome to the Dev Show. So you are from the Netherlands, and you work for Experian as a lead Azure consultant. And you also said that you love serverless, you love dev community, and you're also love creating code. So that's some good things that you love by being on the Dev Show as well. Definitely. You are a co-organizer of Serverless Days in Amsterdam. You're also a virtual Azure Community Day sidekick. And then you also told some really interesting things here. You paint pixel avatars, and you also like to make music.
Yes.
And you have many interests. So two questions two questions from my side. This is two interesting interests, and we just spoke before the show about you maybe showing some of the paint pixel avatars that you have done.
Yes.
I look forward to see that. And then also maybe after that, when you say you have too many interests, what are there any secret interests that we should learn about outside of these two awesome ones?
Well, yeah, I think the drawing the pixel avatars and dabbling with some kind of synth music, but also playing with Legos, for instance, and the creative coding part, making visuals which are interactive. Yeah, it's just too many things I like and too little hours in the day.
Yeah.
So yeah.
That's true.
We all know that. So I'm still waiting for the pixel paint avatars. Do you need us to share your screen to show that?
Yeah, let's do that.
I'm really excited to see those. Okay, so you made those.
Yeah, exactly. Yeah, so this is my Ko-fi page. So if people want one, they can commission me to do one. And yeah, this list is already dozens and dozens of avatars in here.
Nice.
So yeah, and yeah, all of them are different.
Some of them are
it's definitely some Microsoft people, as you can see by the logo there. So yeah, there are really a lot, and it's still going strong. And you also see some new ones coming up on I think on Twitter very, very soon again.
Have you made an Azure Heroes avatar yet?
No, I haven't done yet. No. Okay, I hear a new request coming up for pixelated Azure, right? Okay, yeah.
How can we request?
That would be cool.
How can we request, Mark?
If you go to this page, that's ko-fi.com/Mark Duiker.
Yeah.
Then you can commission me to create you an 8-bit avatar. So
I will share it.
Feel free to do so.
Yeah, that's good. Definitely. Okay. I'm pretty sure Badger wants to make one.
Yeah, exactly. Yeah, that sounds like a nice challenge. Yeah, because now we haven't tried it yet. So yeah. So that shape is quite difficult, I think. But I'm up for it. So let's do that. Sure.
Awesome.
Nice.
That's great.
Yeah, and yeah, music-wise, I don't have any music stuff online, but I did tweet recently about my synthesizer, which is still a work in progress. So it's a modular synthesizer, so that means you buy an empty case with power connections, and you buy all these separate modules, and you screw them in, and then you can connect all the modules with wires, and that's how you make music. So it's really really fun thing to do. So I'm completely new to this. But it's a nice learning experience. It's really
cool.
Yeah, great.
Amazing. Thanks for the insights, and also thanks for showing the pixelated avatars. And I think Sherry, should we step back and leave the stage to Mark? Yep. Take it away, Mark, and welcome to the Dev Show.
Okay, thanks. Let's do this. Okay, let's talk about persistence in serverless applications this time. Well, I already had the introduction, but again, I work for Xspirit. I'm also an MVP now for 2 years because I do lots of stuff in the community, and I really like to share the knowledge. I've also started a initiative with Gwyneth lately, which is called Azure Functions University, where we do a bi-weekly lesson on Azure Functions. And the next one is tomorrow. And of course, more 8-bit stuff, because I really like it. But let's get to the business. So what is the problem when we talk about persistence and serverless? What's the deal here? Well, let's take a step back and look to traditional systems. Because when we still had just maybe one server, either on-premise or maybe already in the cloud, when you need to store some data, you could do that on the hard drive, which belongs to the server itself, or you would move your data to a database, for instance, a SQL database, and life is good. But now these days, when we move to serverless, we have many more servers because sorry, but there are still servers in serverless, but we don't have to worry about the management of that servers anymore. But one request of your, let's say, HTTP trigger may run on one machine, but another request may run on a completely different machine. So it doesn't make sense anymore to store data on one hard drive of your servers, because if your load is very high and many servers are in use, if you store some piece of data like a file locally on a hard disk, it might be available on one of them, but it's not available on the other ones. So that could be a problem. Another thing which could be a problem is that you might make a lot of requests to your database. So if you have, let's say, a smallish instance of a database, and you have now tens or hundreds of servers running because you do a scale out of your serverless workload, you might overload your database. So things might not be stored anymore or not on time. So you really have to think about the scale of that you're working. And so it's really mostly scaling issues. And if you have a very low scale, then you're fine. But since the nature of serverless is that it can scale, and it can scale quite rapidly, and sometimes you don't have much control over that, you really have to think about a different way to deal with persistence of your data. So the solution is really to use a scalable storage system. And luckily, Azure provides quite a lot of those. There are more, but I'm only going to touch these 4. I'm going to talk about Blob Storage. I'm going to talk about table storage, about CosmosDB, and durable entities. And I can't do them all in depth because I could fill a session about each of them individually. So let's go through this. The reason I picked those 4 now is because they're very easy to run completely locally. So you don't even need an active Azure connection or an Azure subscription right away. So also the demos I'm doing them completely on my local machine. So here's an Azure function, and a function is always triggered by something. So it could be triggered by a timer, so it runs every hour. It could also be triggered by an HTTP request. It could be triggered by a queue message, anything. And sometimes, for instance, when it's triggered by a queue message, that message has a payload, and sometimes that's the only input you need. But quite often you need more input in your function. And what's also quite common is that you want to have an output of your function to store some data or to pass some data on to a next function. And the input and output parts, that's what I'm going to talk about in the session. So those are called input and output bindings. And they are a really easy and lightweight way to get data into your function using input bindings, and to move data out of your function into storage by using output bindings. So I'm not going to talk about the trigger part, although those are also very useful. For instance, if you put a new record in a CosmosDB collection, you can also trigger a function. But in this session, I'm also only going to talk about input and output bindings. So let's start with blob storage. So blob storage is about storing large amounts of unstructured data, which actually means files. And so they could be image files, or they could be zip files, or JSON files, or VHD files. Anything related to that, blob storage is the best for that. And Azure has, in the storage account, they have a concept called blob storage. And that existed since, I think the beginning of Azure. It's probably one of the oldest services there is. So it's been around for quite a while. And it's super, super good to use it. So when you go to your storage account in Azure, you will see that you can create containers, blob containers, and inside those containers you can create blobs. And so the structure you have is, first you have a storage account, but within that storage account you have different storage options. One of them is for blobs, and if you go there, you can first make containers, which are sort of folders, and inside those containers you can make blobs, and one blob is then equal to one file. So let's have a look how we can actually use that. So I have prepared a repository. I will share the link later to it, so you can also do this yourself. I have a function app called Serverless Persistence. And in there I have some folders to demonstrate the different kind of bindings. So first let's have a look at the output bindings. But before I'm going to run the code, I need to explain something else. And I already mentioned I'm not using Azure right now. I'm running completely locally. So how does it work? I am using emulated storage. So there are a couple of tools. There is the Azure Storage Emulator, and that's the one I'm using. That only works on Windows. But if you're on Linux or on macOS, there's also Azurite. So both of them are emulator storage, which you can use instead of the real storage account in Azure. To visualize what you have in the emulator storage, I'm using this, and this is the Microsoft Azure Storage Explorer. So you can, it's a free download. It's a cross-platform tool, and you can use that to manage your data, both which is emulated, because I'm looking at my emulated storage right now, but it also connects to the cloud. So this is just a management tool to easily visualize and manage your storage accounts. So this is what I will use for looking into blob containers and to tables later. Okay, so let's go back to the code and let's have a look how we can actually run a function. And all the demos I have are HTTP triggered functions because they are quite easy to demonstrate. And in all these HTTP triggered functions, in this output folder, I'm storing the request, what I have, and I'm storing that as a blob, as a JSON file. So what we see here is an Azure function. It's an HTTP trigger. It's triggered by doing a post. And what it receives is a player object. So what I'm posting to the endpoint is a player object. How does it look like? There's an ID, a nickname, an email, and the region. So this is the trigger, but how does it work then to actually make sure that we can store this in the blob store? That's by using this blob binding. And there are several ways you can use it. Here I'm using it with an output parameter as a string. So I'm outputting a string called player blob to blob storage. And the first parameter you see here is a player's container. So this is the whole path that it will use to store the blob file. So it will store it in a player's container, then it will store it in a subfolder called out, and then this will be the name of the blob file. So it'll be string, and then a hyphen, and then this is something special. This is a binding expression, and when this is run at runtime, it will generate a random GUID for me. So I can run this function over and over again, and each time it will generate a new file name because I have a new GUID created. And I need write access to the blob store. Well, that's the only thing you need for having a blob output. So let's have a brief look at what happens inside the method. I set the default value for the player blob because I need the default value because it's an out parameter. I initialize the result for the HTTP function. I then check if I have a valid player object, and if not, I give back a bad request. And if I have a valid player object, then I serialize it, and then I set that player blob parameter. And finally, I return the result, which is either the bad request or it's an accepted result, a 202. But by assigning this player blob, so at this point, then the blob store will actually write that string to the blob. So let's run this function now locally. So it's now starting up the local Azure Functions runtime. And as I mentioned, it's an HTTP trigger. So what I'm using is the VS Code REST client. It's an extension on VS Code. It's maybe you're familiar with Postman, but with the VS Code REST client, you can also do the similar thing. You can define these .http files and put your gets and posts in there like this. So what happens here, I've defined a variable called base URL. And in this section here, I'm doing a post to this base URL, but then to the store player with string blob output endpoint. And I'm providing it a JSON body. So I'll be posting this, and then we'll switch to, well, let me switch right away, because we will post something to a emulated blob container. And you can see I have some containers here already. So this is my players blob container, and we only see an in folder, but no out folder. So there's no data yet for us, which we generate. Okay, so let's run this. We get back a 202 accepted. So now this should be a record. If you refresh this, we now have the out folder, and in there is our blob which we created. Let me open it. You can see here it's transferring it, so we're actually downloading it, and this is what we created. And so this is the GUID that was also generated. All right. Let's see another sample. Let's go for this one, because there is another way that you could do this. So another way to store blobs is by using a dynamic output binding. Because what we saw earlier is that we had a random GUID in the path name. So that means we didn't really have control over the naming of the blob, which is a bit silly, because you can of course create files with random names in blob storage, but how are you ever find your right data back? So a better way would be to actually provide a meaningful name for your blob file. One of the ways to do that is to use these dynamic blob output bindings. Again, it's an HTTP triggered function, but instead of the blob attribute, we have an interface here, the iBinder interface. And we will use that iBinder interface here inside this else statement. So what we're going to do here, we are going to create the blob attribute at runtime now. And when we create the attribute, we will define again the players collection, the output folder, in this case another prefix, but now we can use the ID property of the player. So we can actually use some valuable identifier for our file. Then we use that binder interface, and that only has one method, a bind async, and we bind to a text writer. And we provide this blob attribute as the argument. By doing it like this, we now have a text writer, which we can use. So on the text writer, we use the write async method, and there we write the serialized value of our player. Okay, so let's run this. We need to go to our blob output HTTP and find the right method. That is this, the dynamic binding sample. So the only thing which is different is the path, because we're using a different function. The content is, well, it's not the same because it's a different payload, but there's nothing much different than before. So let's make this request. So we got a 202 accepted back. So if you go to the storage now, we should also see something here. Let's refresh this. And now we have indeed a JSON, and this ID, which we see here in the file name, is then also the same ID as it is inside the file name, the 693. So that's working. That's cool. Okay. There are some more samples, but let's move to the input now, because this was a way to use output bindings to store data, but let's see how we can use data which is maybe not in the HTTP request, but we want to use that data for further processing. So one of the samples is this. So in this method, again, it's the HTTP trigger, and now it's a get, and we have a route defined with a route parameter. We have an ID, and because we have also specified that ID here, we can use it also in this blob input binding now, because we are now reading from it, and we will read a blob which matches this pattern. So it's a players collection, the input folder, and then there's a prefix of player, and then we have the ID, which we also put in the route. Then we determine if the ID is there or not, but if the ID is there, then we use a stream reader, because we are using an input player stream here. So we get the information from the stream, and we give back a new content result type. We set the content, and we set the media type, and we give back a 200 OK. So let's run this. So now I have to go to our blob input sample with a stream. Yeah, so this is the one. So here we see a GET request with this method name, and then we're providing this ID here. And let me actually also go to the storage to see that it exists. So let's move up one level. So we have two player records here, the 470 and the 4CE. And this is the 470. So let's do the request, and we get back at 200 OK. And that contains the content of that blob. Okay, another thing which we can do is to retrieve, let's say, the blob names for a certain container. So in case you don't want to get back the results of one blob in specific, you want to get a list of blobs which are available in a certain container. Again, what you see here is an HTTP trigger, and we do a GET. We don't have the route specified this time. But now we have a blob input binding, and we just specify the container name. I have it in a constant here, but it just mentions players. That's it. And the type we are using now is the cloud blob container. So this doesn't point directly to a blob. It points to a container, because we want to actually list all the blob names in there. So what we can do with this cloud blob container, there's a list blobs method on there, and we can provide it with a certain prefix, because in this case, I only want to list the blobs which are in the in folder. So I'm doing that right here. And I'm telling it to return the data as a certain type, because blobs are in 3 different flavors, but I want to return cloud blob blobs. Then I'm doing a select on that list, and I also only want to return the names of the blobs, because there's more information on there. It's quite a big data structure, but I only want to return the names in that in folder. All right, so let's run this. It's the blob list one. And this is the result already. So you see we have an array. We have 2 blob names in the in folder, one with the 470, one with the 4CE. So that's also working. Perfect. Okay, let's move back, and let's go to the next one. So we done the storage part now. I did mention this, but most of the time you'll be working with blob blobs. It's the most common one. So those are the files, the JSONs and stuff. The append blobs are useful for if you're doing with log files, because you can write to or append to a log file. And page blobs are only used for storing virtual images of VHDs, for instance. So let's move to table. So table is useful for large amounts of structured data. So that means it has some kind of a schema, some kind of similar structure to it. And yeah, structure-wise, it's more or less the same as Blob, because there is a storage account at the top level. Then you have a table one level below, and in the table you have entities. And an entity is a row in the table. So there are a few properties which are important for an entity. So an entity has a partition key and a row key. It always has a timestamp. And then there are an optional additional properties that you can add. So a maximum of 252 custom properties. The most important thing here is that the timestamp is always automatically generated. So when you insert it, it will have the timestamp. The partition and row key you have to define yourself. And the partition key is, I think, most important, because that defines how efficiently you can query your data and how the data is also scaled. So if you want a very efficient, scalable data storage with table storage, you need to be very careful on how to choose your partition key. A row key is a unique entry within a partition. So you can have partition A and partition B, and both the first records could have row key 0. Okay, so let's move to the code. So let's go to table. Let's first have a look at one of the output samples. Get rid of this. So again, we have an HTTP triggered function, but you don't see a table attribute here, where maybe you would expect it, but the table attribute is here. It's on top of the method definition. And by doing it like this, you indicate that this is a return value which goes to a table. So it maybe looks a bit strange, but this way, by using this attribute with this return specified, you tell it to output to a table. And this is just a constant again. So this is a player's table. Let's quickly show the table so we can open this. So this is my player's table. So at the moment it's completely empty. So that's good to know. So what it will do, it will read a player entity from the request. So it's a bit of a different data type than before. So let's briefly have a look at it. So this player entity inherits from table entity. And why is that useful? Well, the table entity has these things like the partition key and row key. So that makes sure that you always define those partition keys and row keys. What I'm actually sending is a player object with just a region, ID, a nickname, and an email. But the object I'm sending in the request doesn't contain a partition key and row key yet. So that's what I'm doing in this setKeys method. So I'm getting the content of the request that has these properties, but I still need to set the partition and row key. So that's what I'm doing in the setKeys method. Finally, I'm returning the player entity, and that is since it inherits from table entity, that's a correct output for this table. Okay, so let's have a look at that. So it's table output. So what I'm going to provide in the payload of the JSON is this, and this means I'm automatically generating a GUID there. So let's do this. And the response is 200 OK. So let's check what's in our table store. Let's refresh this. And there is our entry. If you double click that, we can look at it a bit better. So it's the ID was generated. We have a nickname, email, region, and we can see that the partition key is equal to the region. And the row key is equal to the ID, because that's how I define it. Okay, so that works. Perfect. Let's go and actually see how we can get something out of that table. So that's this sample. We have here is an HTTP triggered function again, and now we have a route, and the route has two route parameters, a region and an ID, which are also available as parameters here, and that means that we can also use them in a table binding again. So this is a different way of having an output binding, an input binding now. So we use the region and the ID from the request, which is a GET request, and we put that in the configuration of the table input binding. So we specify we want to go to the players table, and we are going to query it based on a region and an ID. And it gives back a player entity, and then we're just giving an OK object with that player entity. Okay, so let's go to the table input sample now. Oh. I want it over here. So we're going to query both on region, but also by ID. So that means I need the ID. So I need to make sure that I copy this ID from here. Make sure that works. And yeah, it's the region. The partition key is UK, so that will also need to be adjusted. So we need to make sure the ID matches, and this needs to be United Kingdom. So when we make this GET request, it should get our object back. So let's do this. So here you can see we're using this endpoint with the region and the ID in here. And we get a 200 OK back. And indeed, here is our information. So as you can see, there's more information. Well, yeah, there's exactly the same information in there. The only thing extra is this E tag, which you don't see, but is always available in entities. All right. Let's go and do the CosmosDB one. So CosmosDB is quite a bit newer than the other storages which I mentioned, the table and blob ones. It's a NoSQL type database. It performs really well, and it has some really key characteristics which has no other alternative in Azure. So it allows for easy global distribution worldwide. You can have different consistency levels for your data in there. So it means, if you want to be able to write a lot to your data, or is maybe important more to read from your data, then you can configure that quite easily. It auto-scales, so you don't have to worry about that. And it also offers various APIs. So I'll be using the SQL-based APIs here, but there's also a Gremlin API for more graph-based data storage. And so there are few different flavors there. So it's a really super powerful database. If you look at the structure there, it's structured a bit differently. When you create it in Azure, you first create a CosmosDB account. And in that account, you can create several databases. And then each database can have one or more collections. And the collection then has items. So it has one layer more. And based on which API you actually use, there are different names for collections and items, but these are the most generic. So it's perfect for NoSQL, so I'm storing some JSON data in there. Again, what is very important here is every item needs to have a unique ID in a collection. And also here, it's very important to choose a good partition key strategy. Because that will actually define how the load is then divided over different servers on the backend. And that has impact on how fast your queries are going to be. Okay, let's go to a CosmosDB output sample. But first, I mentioned before, we're running everything locally. The storage emulator I told you before only does emulation of table storage and queue storage and blob storage. But now we're dealing with CosmosDB. But luckily there is another tool specific for CosmosDB emulation. So I'm running the tool, and that exposes a website which just runs on a local host. So this is my window into my emulated CosmosDB storage. So you can already see I have a GameDB database here, and in the database I have a players collection. In that collection there are items, and this is the items which you see here now. So I have already 3 items here in this database. So let's add another one. First we are going to CosmosDB and then the output. Let's use this one. So what we have here is a function, again HTTP triggered, and again we use this return syntax and then specify the CosmosDB binding. And that binding requires a couple of parameters. We need a reference to the database, in this case GameDB. We need a reference to the collection, which is players. But we also need a reference to a connection string, and that's in this case a connection string name. And that connection string name locally lives in a file called local settings.json. But when you publish it to Azure, that needs to be available as an application setting. Well, first is pretty empty. We get a player object in via post, and we just immediately return the same player object to store in Cosmos. Let's do that. So let's go to the Cosmos output. So here we go. So we're going to store this object in Cosmos. Let's send it. And we get a 200OK back. So now there should be an additional record here. So let's update this. Yeah, and now we have a fourth one. So that's working. I'm probably already a bit over time now. Shall I still give a sample for the durable entities, dear hosts, or shall I skip it? What should I do?
Hi, Mark.
Hey.
Definitely. I think you should carry on. We still have at least 10 minutes to go, so
Okay.
just carry on.
Then I'll definitely do it. Cool. Thanks. Let's see. I'll do the Cosmos input then first, and then we'll still do the entity one because that's very nice, new and shiny. So that's always nice to do. Let's first do the Cosmos input. Still, so let's get a record based on a region and ID, the same thing as we actually did before by table storage. So again, it's an HTTP trigger. We have a route where we specify the region and an ID. And now we have this input binding where we specify again the database connection string, but we also specify in which partition key we are searching. In this case, it's region, and in which ID you want to pick. So it's really a point query. We just want to have one record. And once that one record is found, we will immediately return it. So let's do that. So I know this ID is in there. So let's make this a request. And indeed, we get Grace Hopper back. Perfect. Okay, so let's now get back to the slides and talk about the last item that's called durable entities. So that's definitely a different beast compared to all of the other storage options we had so far. Durable entities is part of durable functions, and durable functions is an extension on Azure functions. But an extension in like it's a code extension, and so it's not a storage service per se. It's just a NuGet package if you're running on C#, or it's an NPM package when you're running on Node. So it offers additional functionality, but under the hood, it uses a storage account. So that means we have table storage which we can use, and we have queues, and we have blob storage. So durable functions is an extension, but it uses a storage account under the hood, but you don't have to have any knowledge of the storage account. That's completely abstracted away from you. You only need to know durable functions API then, in this case, durable entities. So what is an entity? You can compare it with an entity as an actor. And so it's usually defined by a class, and in this case it's called an entity name. So usually it's a class definition. And if you want to have access to a specific entity, you need to provide an entity ID. And as you'll see in the code, it is in a real class, and that class can have properties, it can have operations, and you can expose these properties and operations through the API. For instance, we'll see it because we have a high score example in my demo, and we can very easily store the high score, but you don't really see where it's stored. It is stored in table storage, I can tell you that, but you don't need to have any knowledge about that. So let's have a look how that looks like in code. So let's start with the high score class definition. That's probably the easiest. So here we have a high score class definition. It inherits from a self-made interface. I'll show you that later. But what it has a current value. And so that means we want to do something with the high score. We want to increase the high score with this add method, for instance. We can provide it with some points, and then we add those points to the current value. Or we can reset the high score. We set it back to 0. This is an instance of, well, this is the definition of a durable entity. And because we have this public task run, and we have this entity trigger attribute here. So the syntax-wise, maybe it looks a bit weird and unfamiliar, but this allows us to use this high score object and to increase its value by using this add method, and by also requesting its state by using this current value property. If you look at the high score operations interface, that has the do methods we saw before. So we expose a add operation and a reset operation. And in this sample, I'm only using the add operation. So let's go to the function which is actually using this high score. So what we see, we have an HTTP trigger here, and we can trigger it by doing either a get or a post. And we're using a route with a player name and an optional points route attribute as well. And what we see here, we have this special output binding, and with this binding, we have access to something in durable functions, which is the durable client. So what we will do is, well, depends on the post or get, but what we always need, we need a reference to our entity. And in this case, I want to store high scores, and high scores always point to a certain user. So what we do here is we create a new entity ID, and that's the name of our class, the high score class. And the specific ID is then the player name, and we get that from the route. So then we have an entity ID, and we can do several things. So in case we do a post, that means we have the player name and we provide some points. So what we can do then is parsing the points, because I can get it as a string. What we do, we use the durable client to signal our entity that we want to do an operation on it. And in this case, I have my operations defined in this interface. So if we use this syntax, we say, make this interface available for me with this entity ID, and make sure you increase the high score by calling this add method by adding these points. So this indicates that you can call a method on an entity, and that's a one-way signal. So that's why they call it signal entity. You just do something, but you don't get a response back. So it's kind of a fire and forget. So we will do it in a moment. The other thing you can do is when you do a get method, then you only provide the player name, you don't provide the points. Then you want to know how many points the player has. So what you then do is use the durable entity client and do a read entity state. There you provide the complete entity type. You also provided the ID, so you know which player it's about. You check if the entity exists, because maybe you're using a player which doesn't have any points yet, or doesn't exist in the game, for instance. And if the entity exists, we can actually go to the entity state of that response, and then have access to properties we defined on that high score type. In this case, we want to have the current value. All right, so let's see how this works. The application is still running, so I can invoke it by durable entity one. So I either do a post. I already have a player name. The player name is Grace, and I have a variable for the points here. So when I call this, I will increase the high score for Grace with 50 points. But before we do that, we might want to check for, okay, is the player already there, and do they have points? So let's first do the get, and we see yes, there is a Grace entity, and she has already 200 points. Okay, perfect. So now let's make the change, and so let's give her another 100 points. So let's request. So now we have added 100 points for player Grace. So let's do the get again. And now she has 300 points. And so there is something that keeps track of that state. And that state is not only kept in memory because I can just stop it and run it again, but that state is kept somewhere else. If you want to know, and of course you want to know, I hope, that history is kept in a table. And you see here that partition key is at high score at grace. So Drupal functions is taking care of this partition key and row key and of this whole table and management. But in here you will see a reference to the state and the actual value. This is a bit of insight how Drupal functions and Drupal entities actually persist their state. But like I said, you don't have to have any knowledge about this, how this works. You just need to make sure that you are using the API by either signaling, so that's the one way, or by actually doing the two-way one, and that's by reading the entity state. Right, so I've very briefly shown you four different options how you can use persistence in serverless applications, and yeah, I think these four are really good candidates for you to work with. So some of them already very old, like Blob and Table. Some of them are a bit newer, like CosmosDB and Drupal entities, but they definitely all have their use cases in very scalable and event-driven architectures. I prepared a list for you with some links for all of these topics, because the Azure documentation is quite good in describing all these things. Also, how you should define your data model when using table storage or CosmosDB. How can you define the best your partition keys? So feel free to have a look at this link, which points to a gist on GitHub, where I've prepared some links in a Markdown file. So yeah, thank you very much.
Thank you, Mark. Amazing, great demos, and the demo guards were with you, as we just talked about before. So remember to sacrifice something after the show.
Exactly.
We got at least one or two questions. Yes, it works. so just wanna bring one of the questions up here. So Duncan is asking, are the setup methods and durable entities guaranteed, or is there some way an error is returned if it fails?
Ooh, that's a good question. I don't know out of the top of my head, actually. It's still a relatively new thing, so I haven't actually get into the nitty-gritty details if all of the fire and forgets are actually guaranteed deliveries. I have to look into it. I'll come back to that, Duncan. Yeah, good question.
Great. Yeah, Sherry, any questions from your side, or should we?
Let me see. Are you sure there were not more? Oh, there was also one other questions here.
Sorry, I oversaw that.
Right. Yeah. So the extension is called the Visual Studio REST client. If you want to go back maybe to my screen, then I can show it. But it's this one, the REST client. See, over 1 million installs, 5 stars. So it's definitely quite popular to do this. You don't have to leave your Video Studio environment for this. So that's what I really like about it.
Yeah, great. Yes. So thank you very much, Mark. It was a really great talk. And
thanks.
Yeah. So I guess up to you.
Yep. Yeah. So both Sherry, myself, and also Mark would like your feedback here. Both in terms of did you like the session? Do you like the setup still? Do you have any suggestions in terms of which sessions do you would like, or which topic do you want us to bring up in the future? Remember, this is all of your show, so you choose the content here. So we want to bring what you want like here. So you can both use the feedback form with the QR code. You can use the chat. You can also use Twitter or Twitter handle here. So multiple ways to give us the feedback, but we love to get feedback. And as Sherry said, there's also a small gift if you give the feedback.
Yes, yes, definitely. We have one of you will get like a surprise gift from us, and surprise is good. Don't worry.
Surprise.
Yes. And also the other gift that you all will get is the Azure Heroes Learner Badge. So Baha asked about this program. So it's like a community program from Microsoft. Is based on the public blockchain. So each of these badges that you get they are pretty unique as for yourself. They have a unique URL that you can share it on your social media, and so on. And it's not connected to any account. So it's a kind of that they are 100% anonymous, unless you want to yourself to share it with the others. So all you need to do is scan this QR code, and if it's the first time that you're getting this badge, you need to install a digital wallet to collect your not only Azure Heroes, but if you have other kind of blockchain programs that you want to keep it, and it's built by one of our partner, which is called Engine. So you download that one and then get this badge, and you can go on aka.ms/azure.heroes to read more about the program and all the other badges that we have. We recently added 2 new badges. One is the Green Contributor, for the people that for the developers that they are trying to make a more greener application and have sustainability as their core priorities. And the other one is for the open sources, for the people that they are contributing to the open source, and they are making the open source community more inclusive as well. We have a lot of badges that you can either collect it and nominate it yourself or your other friends. And this is the Azure Heroes .community that if you want, you can click on the that showcase your badge, and you can add yourself to this worldwide map and also find the other Azure Heroes around you. I guess I think if you go to Denmark, you can find Rasmus there as well. So but yeah, and anytime that you want to remove yourself from this showcase, you can also totally remove that as well. So it's volunteer. And upcoming event, Rasmus.
Yeah. So the next 4 topics on the Dev Show. Next week, Vakas will be back talking more about what they do internally in Maersk. And this particular session is about micro frontends, so that's definitely something to come back with, to watch. And then the week after, we will have Apache Spark with Jan Kortz, Microsoft E. And after that, speaking about green development, we will have sustainable software engineering with Asim. And the week after, again, sustainability, building green progressive web apps with David. So a lot of topics to come back for, and see the full agenda on the meetup page, aka.ms/devshow. Yeah.
Yes, and while we have also another Batter's Deck. so there is we have the virtual Azure Community Day coming up on 3rd of December. So it's a quarterly community conference, and make sure that the call for paper is closed now. It's a little bit too late. If you have any idea, sorry, next quarter. But you can add it to your calendar and then make sure to join it. Mark, you were a host on last Community Day. True?
Yes, definitely. Yeah, it's a really nice community event. So I think there were 4 tracks last time, probably also this time. So there's really lots of content from really nice speakers all over the world. And I'm also happy to be hosting actually with the next session as well. So I'm definitely looking forward to this one.
Yes, and sorry, last time I was supposed to be your co-host, but I didn't.
Yes.
Sorry, but this year I promise I have there is one of the tracks is going to be hosted from Denmark with some of with actually Azure user group Denmark. The whole user group are going to help hosting that on
Cool.
December 3rd. So and why we have this one again? Oh, this one was for the CFP. Sorry, so I had to remove this one. But while we have, as you notice on the agenda, that we call December like a green month and focus on sustainability, whereas Microsoft has November as focus on .NET. And so this year, if you're actually .NET is your main focus area, there are a lot of content coming from Microsoft, including the .NET Conf, which is actually happening right now. If you go on Microsoft Learn TV, you can join the Microsoft the .NET Conf as well, and follow the social media from Microsoft, the developer channels. There are a lot of content about the .NET right now, and including the Cloud Skills Challenge as well. So this is also focused on .NET. So the Cloud Skills Challenge is a really interesting concept from Microsoft that you can go on Microsoft Learn and then team up with your friends and compete against the others. And there, as more you learn, you get more points, and you can come up on the leadership board as well. So this is the URL, and yeah, check it out. And if you want to be in contact with Cosmos and I, the best way to actually contact us is via Twitter. Both of us, we have our DM open, and we are, apart from filling up the feedback form, you can always give us feedback here as well. We really want to improve, and we really want to make the show that you like the most. And yes. Thank you for joining us, and thank you, Mark, very much. And
Thank you.
see you next Tuesday. And great. Have a nice evening.
See you. Bye-bye.
Bye.